Then we come to the next section, which is concurrent activity. So these two sections here, these two sections here, this summary of the session's other activity and other activity details, which is missing from this year because there wasn't no other activity. These two sections cover these other SQL IDs, but sampled for the sessions that we're currently looking at with this analysis, whereas the following sections are now, as I outlined in the initial part of the tutorial, the next sections are now about the concurrent activity. So this is about the activity of all other sessions that were not involved in this SQL execution analyzed. So this is an information that you do not get from the real-time SQL monitoring. This is simply not part of the analysis that you get from the real-time SQL monitoring, that it gives you an idea about what else happens during the execution analyzed on the system. And in case of a cross-instance activity, cross-instance parallel execution, you would see here even the breakdown on global level and on instance level for all instances involved in the execution. So this is, I think, sometimes quite helpful part of the analysis, so that you get an idea what kind of activity was taking place else on the system. Was there, for example, a lot of CPU activity, which might explain something that you see here for this main SQL execution. So maybe you have a case of CPU starvation, or maybe you have a lot of temp activity, high PGA usage, things like that. You can see from this concurrent activity sections how much resources basically were in use by other activity during the time this main SQL execution that gets analyzed was active. So therefore I think this can be quite handy, this part here. So the concurrent activity here is, again, you get a global summary. So the global summary is simply a one-liner that gives you the high-level overview of all other activity that was found in active session history. That is the nice thing about active session history, that is system-wide, global, but at the same time allows you to slice and dice and drill down to the information that you would like to see. So in this case, I give you a summary here of all the other samples found. So we can see here, for example, these 142 samples found. There were 73% out of these 142 samples were CPU activity. So these 142 samples are in relation to these 49 seconds of duration of the main SQL execution, this 142 seconds of database time. In principle, then tell you that there were on average almost 3 other sessions active. So this gives you a rough indicator. Since it's an average, you have to be careful, but it tells you on average during these 50 seconds almost 3 other sessions were running on the system, and 73% of this activity, so more than 2 sessions were on average on CPUs. So this tells me already that 2 CPUs on average were in use by other sessions. So if I, for example, only had 2 CPUs on my system, then this would already be a quite important information and indicator that there might be some problems with the CPU usage. And therefore, as I said, I think it can be quite helpful. The middle value of the average active sessions were then 3, and the maximum found in this samples, the maximum number of active sessions concurrently of other sessions active were 5, the minimum 1. And as I already said, you see here the maximum PGA allocated found in these samples if it's 11.2 or later, the maximum temp allocation found in these samples, the differentiation between foreground and background activities, so this can also be sometimes quite interesting. So most of these samples here were about foreground activity, only a couple of samples were background activity, and we also get information about the number of parallel execution servers found. Again, the same differentiation between count and unique count applies that I already mentioned in the global ASH summary for the main execution, which means that this is just about the distinct names that could be found, if you want to say so, and this is the distinct allocations, if you want to say so, found, because it includes the serial number, and the serial number then changes every time PX server gets reallocated. So in this case there is no difference between the two, but if you had the case of PX servers that were allocated and released many times, then these two values could be quite different. Then the number of different clients, processes, transactions, and so on. This corresponds to what I've already explained, and you have the same. You have to take into account the same that I've already explained. So these counts are not absolute counts, but based on the sampling. So you have always set that in relation to the number of samples found, and then we get here these well-known flags for describing the type of activity. If there were multiple instances involved, then we would see something like this here. So we get again here this instance ID indicator, and this instance ID indicator therefore gives me the idea here. This is a global summary, and then I get a summary for each instance. So that is the idea. For example, here you could see that this instance here had one session on average active of other activities, whereas this second instance here had almost no other activity. So this global summary here wouldn't tell you this difference in activity between the instances, and therefore for multiple instances involved you get this in addition you get this on instance level, this information. Yeah, and which means I can already continue with the next section, and this is still about this about this concurrent activity. So this is about the same samples that were covered by this section here, and you get here now the information about the different kinds of activity that were found in the active session history. So was it CPU activity or IO activity or concurrency or whatever. You will see here either the CPU activity, in the latest versions also the differentiation between in-memory CPU activity and non-in-memory CPU activity, and if it's not CPU activity, then it should be covered by one of the wait events, so that the session is actively waiting for something, doing some system calls, waiting for them to return. So you see here the corresponding wait events along with the activity class information, and you get here then a breakdown of how these samples were then allocated. So in this case you see here again this 73% of CPU activity and 23% were then here this direct path read temp concurrent activity, and you get here a graphical representation of this activity pattern. So which is not just which is just this percentage here in a graphical representation. And the next section is then about the concurrent activity top SQL IDs. I think it is by default it's the top 5 SQL IDs found. Again, this is sorted by sample count descending, so the SQL IDs with the most database time come first. So that is the top order of these, and again you see here the SQL ID. If available, you see the text, and the top level SQL ID, first sample, last sample, and so on. It's pretty much the same that you get for these other activities. So there are pretty much the same values. Also the time active graph and the flags. One thing that I think I haven't made maybe that entirely clear is that whereas the main explain-ash analysis is about a single SQL execution, of course this other activity and this concurrent activity in principle can cover many different executions of these SQL IDs. So this is not necessarily representing a single SQL execution of these concurrent and other activities, but is then a summary of these different executions. So the summary level here is on SQL ID, which might cover as many different SQL executions as there are covered by these active session history samples. So that's maybe some important point to mention, that these in this information here is about this SQL ID, which might mean many different executions of this SQL ID. And then finally, for the concurrent activity, you will see here the I/O summary, and this is the I/O summary for the concurrent activity. So this is the fourth section. 1, 2, 3. It's the fourth section which is covering this concurrent activity. So this is from 11.2 on. This gives you a summary of all the I/O activity that could be found for this concurrent activity. So more or less everything which you can extract from this active session history samples, starting from read requests, write requests, then giving you an idea about average read and write requests per second. The same for the read bytes, write bytes, and from 12C on you even get these logical reads from cache. So this I've called here total read memory bytes. The total I/O layer bytes, which is for non-Exadata environments simply the sum of these two. However, for Exadata you have here the possibility of seeing totally different values due to this difference between what does the database see as activity and how much data is actually then exchanged between the compute nodes and the storage cells. So for example, if you have here a query which is making use of smart scans and does this offload, then the total I/O layer bytes might be far less than the actual volume of bytes read from a database layer perspective. And likewise, if you, for instance, have writes to the storage cells, if you make use of normal or high redundancy, then the total I/O layer bytes could be 2 or 3 times more than the bytes written from a database layer perspective, because Exadata then does this duplication of data, this mirroring on ASM layer, and therefore has to send 2 or 3 times amount of data to the cells to fulfill this ASM redundancy. And of course, if you have a DML statement that does reading and writing, then you could easily end up with a mixture of offloading and writing. And if you deal with compression, then again you can have different I/O layer bytes pattern, because the compression, the decompression happens on the cell level typically, which means that the amount of data that gets exchanged between the cells and the compute nodes can be much more than the data read from a database layer level, because the cells decompress the data and send the decompressed data to the compute nodes, and this is depending on the compression level, then much more than the segment size that gets scanned. So these are all different types, kinds of patterns that you might see with exadata, and therefore this I/O layer bytes here becomes pretty relevant in exadata cases. For non-exadata cases, as I said, it doesn't really add that much value, because it's simply the sum of those two. Yeah, then you get the corresponding averages. So this gives you here maybe something like an average read and write bytes per second, which might be interesting if you're looking into I/O performance issues. And even the average read and write request sizes you would see here, and also minimum and maximum values. So you would also see here peaks and outliers in some case, if you had to very slow or very fast I/O patterns. And for exadata, based on this official, not necessarily that useful official formula, you would get here the cell offloading efficiency percentage for non-exadata. This will always be 0 and should actually be not there, but I do not differentiate here between exadata and non-exadata, so therefore it's always there, but only relevant if you happen to have an exadata storage. So this gives you the I/O information for the concurrent activity, and in the next section is exactly the same, but is then, now we return to the main SQL execution analysis. So this is the same I/O pattern for the same I/O information for the main SQL execution. And this also means that, which I find sometimes quite helpful, if you then see here the total volume, let's say, or the average speed of the concurrent activity and the average or total volume of the main SQL execution. If you put these two together, then you see in principle the overall system-wide activity in terms of I/O. So you have them here together, so you get a nice comparison. Let's have a look at a different example where we actually have some I/O activity. Let's see, maybe here. Well, this is just the other one which was analyzed. So you see here the concurrent activity corresponds to exactly to this main execution and vice versa. So this was obviously taking place at the same time. Let's see, maybe I have a different example where we have nope, not here. Well, that's maybe a good idea that I show you this. If you, again, for multi-instance reports, in this case you actually get different sections. So you get an I/O summary. Yeah, well, maybe I just return to this one here first. So as I already said, you get here for this concurrent activity, you get this global and instance level breakdown. This also applies, of course, to the following sections. So you see here again this global and instance level breakdown. And in case of the I/O summary, you actually get not the same. Do not get a single section with different levels, but you get then actually different sections. So this is the global summary, and then there is on instance level there is a different section which gives you the information on instance level, and but apart from that, it's pretty much the same. And the same applies then, of course, to the I/O summary for the SQL execution analyzed. So you get here again this information on global level and then on instance level, which is apart from that, again, exactly the same information, just give that you can spot whether some instance was involved in more or less of the total I/O activity.